I am Anil Kumar. Welcome to my series on rational exponents. We'll actually share with you some examples from previous test papers where we need to work with rational exponents. Here are a few important things to remember. So if we have, in general, when we are talking about exponents, if we have something like a to the power of n multiplied by a to the power of m, then the exponents add up if they have the same base, and it becomes n plus m. If we have this in division form, quotient form, in that case it becomes a to the power of n minus m. Right? Remember, if we have something like a to the power of minus p, for example, it could be written as 1 over a to the power of p. Right? So it kind of flips. Now when we talk about radical and rational exponents, in that case sometimes we may have something like this. We may have something like a and we have nth root and m power. This really means that a to the power of m over n. Do you see that? Now you see that rational part? So those are type of questions which we are going to now do, right? So all of a sudden we have this kind of a radical. Sometimes you may also have something like this, one within the other, right? One within the other, right? So let's say this is cube and that is the square root. This basically means that we have a to the power of half, and then again this is the cube root, right? So this becomes like this. And now you can apply these rules which we learn, and you get your solution. Perfect. Most important to remember is this, that a to the power of 0 is what? Is just 1, right? And 1 to the power of n will be also just 1. Now these are very important things to remember, and then it will be easier for you to take up this test. Now I hope with these concepts absolutely clear, let's begin with our test paper. We should be able to do most of the questions with ease. So let's begin our test practice. Here is question number 1. Evaluate each of the following. 64 to the power of half, 10 to the power of minus 3, square root of 256. So the very first one is 64 to the power of half. Basically it means you need to find square root of 64. Well, you can think 64 is like 8 times 8, and when you do square root, you should get 8, right? So 8 is your answer. Well, there's no need to do all these steps. You could straight away also write 8 as your answer in your test paper, right? I'm trying to show you all the steps so that it's good for all of you. The next one here is 10 to the power of minus 3. That negative here means you could write this as 1 over, right? 1 over 10 to the power of 3, that means 1 over 1000. So that becomes your answer. Well, if you want to write it in decimals, it will be 0.001, correct? So basically you move your decimal 3 places, right? So first place 0.1, second place 0.01, third place 0.001. Now we are into this square root of 256. Now I've taken this purposely since I want you to remember what are the powers of 2. Now whenever you're working with exponents, 2 is a very important number. So if I have 2 to the power of 0, it is just 1. 2 to the power of 1 is 2, right? 2 to the power of 2, square of 2, which is 4. 2 cube is 8. 2 to the power of 4 is 16. Keep on multiplying with 2, right? And then you get these powers of 2. They really help you to answer many questions, right? So that is 256. Do you see that? Let me continue, and we get 512. And the last is, let me write here, 2 to the power of 10 is 1024. Now this is a very important number. Even if you remember 2 to the power of 10 kilobytes, you understand, kilo means 1000. So it is a number very close to 1000. In our binary system, we always take 2 to the power of 10 in our calculations, kilobytes, 1024, right? So you could do reverse calculation. 2 to the power of 10 is 1024. 9 will be half of this, 512, and then half of 512 is 256. You get the idea, right? So this is a very important number to remember. So I'd like you to go through this sequence and get it so that you could easily work with rational exponents. Also, look into the series by 3 and 5. So when we say this 256, you could work like this. We are actually saying 256, which is to the power of half, and then again we have a power of half over it. That is the meaning of these two square roots. And 256, as we just saw, is 2 to the power of 8, right? So you could write this as 2 to the power of 8 to the power of, this is 1 over 4, right? So correct. So that is how it is. So now what we really get here is, because you multiply these to get 1 over 4, and 256 is 2 to the power of 8. Then you apply the rules which we saw in the previous page, multiply them, so you get 2 to the power of 2, which is 4 as your answer. You get the idea, right? So that is how you're going to get the solution. Correct? So in steps, if I am working with 2 to the power of 8, then half of 8 will move from here to this place. Correct? And half of 4 is 2. Do you see that part? Visualize it. So we get our answer. So first square root will give you 16, and the next square root of 16 is 4, which is our answer. Perfect. So you could do in this fashion also. So I hope it makes sense. What I'm trying to say here is like this. The question was square root of 256, right? So we could have written this as square root of 16, which is equal to 4, right? But working with 2's power is very flexible and better to do. Now let's move on and take the next question. This time we need to simplify. So we have a to the power of minus half. The print is not all that good, and therefore I'm rewriting. So you just multiply power of power, so you get a to the power of minus 1 over 4. Now many times you are supposed to write without negative powers. So negative here really means that you need to write it as a reciprocal. So it becomes 1 over a to the power of 1 over 4. That 4 is not going to flip. Because of negative, I'm writing 1 over that, right? I hope that point is clear. Now we have a cube, b to the power of 6, everything to the power of 2 over 3. So this 2 over 3 is going to multiply with the inside exponents. That is a power rule which we are going to apply. So we get a to the power of 3 times 2 over 3, b to the power of 6 times 2 over 3. Correct? Perfect. So that gives you a to the power of 3 and 3 cancel. We are left with square. And in this case, b to the power of 4. 3 goes 2 times in 6. Now c is 1 over 8 to the power of x, and in the denominator we have 2 to the power of minus 3x. So let me rewrite this. It's written as this: 1 over 8 to the power of x divided by 2 to the power of minus 3x. Now this minus 3x you could bring on the top. So we could write this as 1 over 8 to the power of x times 2 to the power of 3x. Correct? Negative means just flip it. So if it was in the numerator as it was here, bring it to the denominator. If the number is in the denominator, take it to the numerator, right? Now, we should have same base. We know 8 is equals to 2 cube. So let me replace this 8 with 2 cube, right? So I will write this as 1 over 2 cube to the power of x times 2 to the power of 3x, correct? So now we are adding all these terms. We could write this as 1 over 2 to the power of 3x times 2 to the power of 3x. Now these are same terms, so when you multiply, you get this as 1. Some of you can actually add them up. That means 2 to the power of this 3x minus this, because this is in the denominator, right? So the exponent basically is 0, and that should give you 1. Clear? So the rule, I hope you remember, a to the power of 0 is 1, right? So that is how it is. So they just cancel out, giving you 1. And that is how we know that anything to the power of 0 is always 1. Perfect? So with that, I think the basics are covered. Now let's take up higher level questions on rational exponents. Question number 3. Solve for x. Now here we have 3 equations, right? So we'll try to find the value of x solving these equations. The first one here is 3 to the power of x minus 1 equals to 1 over 3. The idea is to get the same base. So we do have the same base, but we have not written it in similar order. This could be written as 3 to the power of minus 1. You get the idea? So we have 3 to the power of x minus 1 on the left side and 3 to the power of minus 1. Now, both the bases are same, so we can compare the exponents. So we could write now x minus 1 equals to minus 1, and that gives you x as equal to minus 1 plus 1, which is 0. And therefore, our answer is x equals to 0. You get the idea, right? So if I write x equals to 0, what do I get? Let's check it out, right? So if I want to check, I will do 3 to the power of 0 minus 1, which is 3 to the power of minus 1, which is indeed 1 over 3, the right side. So it is absolutely correct. So that is how you could also check your answers while working with solution of equations. It is kind of critical. It doesn't take much most of the time. It's just a verbal thing to check, right? Now here we have 4 to the power of 3x. Let me rewrite. 4 to the power of 3x equals to 3x equals to 8. Now 8 could be written as a power of 2. 4 also can be written as a power of 2. So that is what we are going to do. 2 to the power of 3 is 8 and 2 square is 4. So the left side becomes 2 square to the power of 3x. Now we are going to apply the rules. Power rule, it gets multiplied. So we get 2 to the power of 6x equals to 2 to the power of 3. Since the bases are same, we'll equate 6x and 3, the exponents. And x will now be 3 over 6, which is equal to half, correct? So that gives you the solution. Now this could also be checked. 4 to the power of 3 over 2 is what? So first you do square root, you get 2 to the power of 3, which is 8, so that is also correct. You are getting the idea, right? So that is how we are going to solve such equations. The next one, I like you to pause the video, answer it yourself, and then look into my solution. Now here, what should you do? Well, it is 3's powers, right? 27 basically is 3 cubed, and 81, which is 9 square, is 3 to the power of 4. Good? So think like this. It becomes very easy. So instead of 27, I'm going to write 3 cubed. So I'm not rewriting the question this time. So instead of 27, I'm writing 3 cubed, and we are writing power of 3 cubed is x minus 1, correct? Now in this case, it is 81 in the denominator. Remember this, right? So either you could do, let's do first time 3 to the power of 4 in the denominator, and then we have 4x minus 1. Perfect. Now let's get to the powers of 3. So here it is 3 to the power of 3 times x minus 1, and here it is 3 to the power of minus 4, because it is in the denominator, times 4x minus 1. Does make sense to you? So because this is in denominator, we write this as 3 to the power minus 4. Applying the power rule, we get that. So this time I've cut down on one of the steps. Since we have the same base, we'll equate the exponents, correct? So once you equate the exponents, you can find the value of x. So let's do it. So we have 3 times, so let's open the bracket. Okay, we'll do it in 2 steps. And minus 4 times 4x minus 1. So that gives you 3x minus 3 equals to minus 16x plus 4. Bringing x together, we get 3x plus 16x equals to 4 plus 3, which is 7. And this is 6 and 3, 19x equals to 7. So x is equals to 7 over 19. So that becomes our answer. X equals to 7 over 19. Now that's difficult to check, but we'll leave it there itself and say, well, this is how we could do it. Perfect. So that is how we're going to get the answer. So I'd like you to check this solution once again and then move forward to question number 4. Here are 3 more examples to evaluate or solve for x. So I'd like you to actually pause the video, answer these questions, and then look into my suggestion. This is kind of a review test for you. Okay, let's begin with the very first one. We have 25 to the power of x equals to 5 times square root of 5. Now we should write 25 as 5 squared. So we get 5 squared to the power of x equals 2. This is like 5 to the power of 1 times 5 to the power of half. Now on the left side you get 5 to the power of 2x, and this becomes 5 to the power of 1 plus half, which is 3 by 2. So basically we get 5 to the power of 2x equals to 5 to the power of 3 by 2. You can equate 2x to 3 by 2 now and find the value of x. It will be 3 by 2 times half, which is indeed 3 by 4, right? So we have our answer, x equals to 3 by 4, correct? The next one here is 9 to the power of x minus 1 equals to 27. So let me rewrite 9 to the power of x minus 1 equals to 27. 9 could be written as 3 squared, right? So we have 3 squared to the power of x minus 1. 27 could be 3 cubed. So now we have the same base, so we know how to equate them. We have 3 to the power of 2 times x minus 1, and on the right side is 3 cubed. So we could write 2 times x minus 1 equals to 3 and solve for x. So x minus 1 is 3 over 2, and x is equals to 3 over 2 plus 1, correct? Which is 5 over 2. Do you see how we could solve very easily all these questions now? So you have to be good at working with fractions when you're working with rational exponents, for sure. Okay, now here we have 3 equals to 108 times 1 over 6 to the power of minus 1 over x. So that minus means we could flip this, right? So we have 3 equals to 108, and that could be written as 6 to the power of 1 over 6, right? That minus means to flip 1 over x. Do you see that part? Okay. Now what I'm going to do here is that I'm going to divide this 108 3 by 108. So we get 3 over 108, right? And here we get 6 to the power of 1 over x. Now, when you divide this, what do you get? 3 goes 3 times and then 6. You get 36. And we get 6 to the power of 1 over x. Now, what is 36? 36 is 6 squared, right? Okay, so I could write this as, since there's less space, let me write here. We could write this as 1 over 6 squared equals to 6 to the power of 1 over x. Now this basically means 6 to the power of minus 2, right? So we have 6 to the power of minus 2 equals to 6 to the power of 1 over x. And that basically means what? That means minus 2 is 1 over x. So what is x equals to? Well, that means cross multiply. X equals to minus 1 over 2 with a negative sign, or minus half. Do you see that part? So it's kind of tricky. We have to, go back and forth a couple of times to get that particular answer. Well, alternate could have been, we could do like this. Let's redo this question. So we could write this as 3 over 108 equals to 1 over 6 to the power of minus 1 over x. Now this is, as we learned, is 1 over 36, right? And 1 over 36 is 6 squared, or it is 1 over 6 to the power of 2. And then we could compare 2 with 1 over x minus 1 over x and get our answer. Anyway, the answer will be same. So there are many ways of solving. That is what very sure. So there are many ways to solve any equation, and that's an illustration of the same. Okay, let's take up the next question now. I think we are almost at the end. This is the last question. So we're trying to work with the expressions where the radicals are involved. 125 1 to the power 1 over 3 plus 36 square root plus 32 to the power of 4 over 5, everything to the power of 2 over 3. Now similarly, we have a complicated expression here also. You can actually pause the video, try them out, and then look into my solutions. So let's work with the very first one. Basically, we're trying to find cube root of 125. So let me rewrite this. Cube root of 125, that is what we have written here, plus square root of 36. So if I don't write anything here, it means square root. And 32 is plus 32 is 2 to the power of 5. So I prefer to write 32 as 2 to the power of 5 to the power of 4 over 5. Right? So sometimes one type of expression can help, everything to the power of 2 over 3. 2 over 3. Is that clear? Now cube root of 125 is 5, right? And square root of 36 is 6. And here, when you multiply 5 and 1 over 5 cancel, so we get 2 to the power of 4. And here we have 2 to the power of 2 over 3. Correct? Now this gives you 5 plus 6 is 11 plus, what is 2 to the power of 4? Well, 2, right? 4 times 2, 8, 16, right? So we'll write this as 16 to the power of 2 over 3. We could just add them up, so we get what? 7 and 27 to the power of 2 over 3. Correct? Now how do we evaluate without calculator? Well, all this exercise is without calculator. That is kind of critical to understand. So we have 27, that reminds us of 3, right? So we could write this as 3 cubed. This is critical, right? 27 is 3 cubed to the power of 2 over 3. Does make sense? Now it is easy. So when you multiply, you get 3 squared, which is 9. And so 9 is our answer. Perfect. Very important question from test point of view. I hope you understand and appreciate it. I've seen this question many times in the test paper. Okay? So that is how you're going to work with it. The last question here. Well, this is relatively simple. You just have to work with each individual and then combine them. So first thing is 3 over 12, which is 4. So we get here 1 over 4. That is, we are working with the first term in the bracket. So 3 goes 4 times. X to the power of what? We could write the numerator minus 2, and this is also minus 1. So we could write minus 3. And y to the power of what? 3 minus of minus 1 gives you 4. Correct? So that is what it is. On the right side, when you divide 10 by 5, you get 2. 2 is in the numerator. X to the power of 4. And this is minus in the denominator. When you do minus or minus 1, you should get 5. And y to the power of minus 2. And this is also minus 2. That makes it minus 4. Is that clear to you? So when you open the bracket, you get 2 over 4, x to the power of, add them up, so you get 2, minus 3 plus 5, y to the power of 4, and minus 4 is 0, right? So that is half for us. It is x squared, and y to the power of 0 is 1. So I could write this as x squared by 2 as my answer. Is that clear? So I hope all these steps are absolutely clear and you're ready for your test on rational exponents. You have learned how to simplify them, how to evaluate them, and how to work with them. Feel free to write your comments, share your views, and share my videos with your friends. Thanks for watching and all the best.